open to page 42. We'll take our quick look at the calendar. Today, for the first time all semester, we are not doing something from the textbook. So the material for these next two classes you will not find in the textbook at all. Everything that we're going to do is going to be out of the packet, including the homework assignments. So the next 2 days we talk about cryptography. Today we'll do our introduction. We'll talk about two methods, the substitution method and the BiFID method. Next class we talk about two other cryptography topics, Vigenère and AutoKey. They are more complicated, so today's the intro and the easier stuff, and then it'll get more complex on Monday. Then on Wednesday, a week from today, is our review for test 1, which is happening on Monday, October the 7th. Also happening right now is the due date for the voting project. So if you have a voting project, put it in the folder. If you don't have it yet, get it to me as soon as possible. Lateness penalties start accruing, like at midnight tonight. So you really want to get this to me as soon as you can. I know we don't have class until Monday, but if you have this thing done tomorrow or Friday, slide it under my office door and the penalties will stop accruing as soon as you do that, okay? So don't wait until Monday if you've got it done earlier than that. Any questions on the calendar? Okay, then let's take a look here at the top of page 42. So we'll start with number 1, Stephen. Thank you. Sam, number 2. Okay, anybody do anything electronically today or yesterday or in the last week that they hope the information was secure? Say it out loud. What did we do? Texting, online banking, Facebook, email, Twitter, fantasy football. You want to make sure nobody knows who you're starting this week. Yeah, I got you. So there are lots of places where we want to make sure that our information is secure. Well, let's go to Griffin for 3. Thank you. Okay, so we're not going to be able to prevent people from seeing our messages. The only thing we can do is try to disguise so that it's not obvious what the content of the message is, all right? Okay, so we'll go to number 4, and we're around to Casey. Okay, let's pause there. So when we encrypt, we're going to take a message that makes sense, and we're going to try to make it look like gobbledygook that hardly anybody else will be able to understand. But the one person we do want to understand it is going to decrypt our gobbledygook and get back to the original message that makes sense. Okay, so encrypting and then coming back is the decrypting. A cipher is a reversible rule for disguising a message. What does reversible mean? We can change it back. So here's one way to encrypt a message. Let's say that I have some message that says something like math rules. Okay, so there's the message. I don't want that to get out, so I want to encrypt it. And here's my rule. Here's my cipher. I'm going to take every letter and replace it with the letter A. So what does math become? A. Okay, and then rules. Yeah. Okay, so there's my encrypted message. There's a problem here, and that there's no way to reverse this process, right? That's no good. It's really well encoded, but it's not possible for anybody to get back to the original message. So this is not reversible. This is not a legitimate cipher, okay? So we want something that a person can go the other direction and get back to our original message. Let's go to number 5, Evan. Thank you. Ed? Mary? Okay, so Mary just read to us this thing that is called the Caesar cipher. So if on a test or in homework it says use the Caesar cipher, it is this rule: each letter is replaced by a letter that is 3 places later in the alphabet. That is what Caesar means, okay? Every letter becomes 3 later in the alphabet, always 3. That is what he chose. So for example, the letter A, if you count out, you go B, C, D is the 3rd one later, right? B, C, D, E is the 3rd one later. Everybody see it? What happens when we get to the end of the alphabet? We'll just wrap around at the beginning. So if you wanted to translate the letter Y, you'd say, okay, after Y comes Z, and then if we just start the alphabet again, A and B. So Y goes to B. Everybody see it? Okay. So let's just jump down. Okay, so we'll go to 7, and we're up to, lost it. Brandon. Okay, thank you. So we'll jump to number 9, which references, well, 8 talks about using the cutouts that you guys have in front of you. So here's what I want you to do. We're going to use the cutouts, and we're going to encode this message, attack at daybreak. So remember, every letter becomes 3 later. So here's how I want you to use the cutouts. We have 2 different cutouts. One of them is the standard alphabet as it sits. The other one is 2 alphabets. I want you to put them in this order, with the real alphabet to the left and then the double alphabet to the right. And then the idea is always to take the real alphabet and encode it in this kind of messy double alphabet that I'm standing here. So we're going to take A and we're going to put it right next to what letter does A go to? D. So you match up the A with the D. Everybody see it? A goes to D, B goes to E, but we got to make sure we're clear which way we're going. So encoding, which is what we're doing right now, or encrypting, we're going left to right. So letter by letter, translate attack at daybreak. Before you get too far, maybe when you finish the word attack, just double check with your neighbors that everybody at your table is doing the same thing. Okay, so the next thing we'll talk about once we've encrypted or encoded our message is here in number 10. I think our next reader is up here, Damien. Okay, so what were the first 4 letters when you encrypted? What is it? No, after we D, W, W, B, is that the beginning? And then we're going to put a space. Even though attack doesn't have a space here, we're just going to put a D. Thank you. Then we're going to put a space. What are the next 4 letters? F, M, D, W. Right, see the little space? Every 4 letters, put a space. So just rewrite your answer. Should be FN. You guys are making me look bad here. All right. FNDW, then put a space, then put the next 4 letters. So this is going to be our default. Just every 4 letters, we're going to group them, okay? Doesn't matter how the original message was grouped, like attack is a long word, at is a short word. We actually don't want to group it the same way the original one is, because then whoever intercepts this message gets information and they say, oh, I don't know what that middle word is, but it's only 2 letters long and there's only like 100 2-letter words. So it gives information that we don't want to give. So we're going to intentionally regroup, and we'll just do it every 4, okay? What's the, Jeremy, what do you have next? D. What's the last one? Okay, and then? Do HDN? Okay, we agree? Is that what we have? Is that okay? If there were another letter here at the end, you would just put it. It's all right if it's not perfectly divisible by 4, right? So just groups of 4 except the last one. Okay, next page. Number 11, Barbara. Okay, so here's a message that was encoded using the Caesar cipher, DOO, blah, 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 blah. We want to decode it and write the answer below. Notice that here there are blocks of 5, which is okay, but it doesn't mean anything about the original message. So you're going to use the same cutouts. In fact, they're still going to be lined up exactly the same way. But how are you going to read them to decode? We're going to read backwards. Look at the right-hand one, and then write down the letter in the left-hand one, okay? And check in with your neighbors after the first 3 letters just to make sure everybody's on the same page. Everybody get the message? All work and no play. A lot of people had all cork and no play. So, really the only way to go wrong here, is to read the wrong direction. So again, you have the real alphabet is the single one. I suggest putting that on the left. Then you have the pretend alphabet where there's 2 copies. That doesn't make sense. I call it pretend. When you encode, you go left to right. When you decode, you go right to left. Right? It's the only way to get it backwards. It's just going the wrong direction. You can totally switch them. And the choice that I'm making is kind of arbitrary, but just pick something and be consistent so that you know which way is which. Okay, that is good. Let's go to 12. We are up to Sana. Cryptoquote. Okay, so every letter got replaced by one and only one letter. So for example, in the first word all, there were 2 L's. Where did those 2 L's come from in the original? They came from 2 O's. Okay, makes sense that both O's become L's. But we're going to talk about ciphers where the same letter doesn't always become the same letter. There's a problem with doing something like this, and that's listed out here in number 13. We'll go to Nicole. Thank you. Jeremy? Okay, so taking a look at this histogram, so we have all the letters on the bottom. On the left-hand side is probability or relative frequency, but it's a probability. What's the most common letter used in the English language? It's E. And if you actually go up to the E and then you come over here to the left, then whatever this number is, I'll just say it's, I don't know, 0.125 or something like that. I don't know exactly what it is, but what that means is that 12.5% of all the letters used in the English language are E's. So like if you just go to a book and you count up all the letters and you count up all the E's, roughly 12.5% of those letters are going to be the letter E. What's the second most common letter? T. And the third most? A. And so if you have a long message where it's just a substitution rule, then somebody can say, all right, I see a lot of a certain letter. There's a good chance it's either E or T or A, and they can just kind of start guessing. And if the message starts to make sense, then they're probably doing it right. And if it's gobbledygook, then they'll make a different guess. But with enough trial and error, a little bit of time and patience, these ciphers, these messages can be decrypted pretty easily, which is a problem. Okay, let's go to number 15, and we'll go to Kate. Okay, thank you. Lila? Okay, so let's take a look at this grid. It's going to be a completely new way to encode a message. It is going to be far more complicated than the Caesar cipher that we just talked about. So what I want you to do is put the alphabet in here, A, B, C, D, E, F. Go all the way to the end. What's the problem though before we get there? There's not enough spaces. You're going to completely skip over the letter J. It's one of the least commonly used letters in the English language. So just skip J when you get to that one. Just go from I to K. What will happen at the end to let you know you did it right? You get to Z. That's the goal, is you get Z at the end. Okay, that's fine. So now we're going to go to 17. Jake? Oh, actually, we did that already. Sorry. Go to 18, Jake.
Instead, we'll create a square base.
Continue. Okay, so confidential is going to be part of this translated message. There's going to be a secret message we're going to make, but confidential is like the keyword that's going to allow our friend who's reading this to understand the message. But what we're going to do is write the word confidential in the spaces here. But stop when you get to the second N. Okay, and the idea here is that we still have to get all the letters A through Z into this grid, which means we're not going to repeat anything. There's only room for those letters once. So when I get to the second N in confidential, I just skip it. What's the next letter in confidential? T. What's the next letter after that? Is I, which we skip because you've already written it. So it's tricky. You got to make sure you don't write any letter twice. What's after the I in confidential? A. After that, L. Okay, so you write the word confidential, but you skip any letter the second time you see it. And now we'll go to 19, Aileen. Okay, so the first letter in the alphabet is A, but A already appears from the word confidential, so you don't put A. What goes in the first blank? B. What's the next letter in the alphabet? In the alphabet, C, but C is already there, so you skip it. And you keep skipping until you get to letters you haven't written yet. So you still have to have it. Still skipping J. We always skip J. Poor J. So fill in the rest of these letters very carefully. You'll know you did it right if you get to Z in the last space. If you run out of spaces before you get to Z, you failed. Try again. Questions about filling in the Polybius square? It's not clear what we've accomplished, but anyway, we've come up with a funny way to write the letters A through Z in that grid. Good? Okay, next page. And now we're going to actually start to encode a message. So the directions are here. We're not going to read them to each other, but we'll just do an example and hopefully it will become clear. All right, so first of all, make sure you agree that this Polybius square is the same as the one we just wrote. Starts with confidential and then just the letters that we had before, right? Does that seem reasonable? Okay, so I just put it here again so we could use it on this page. All right, so here's what we're going to do. We are going to encode the word retreat. That is the secret word. We're going to try to encode it so that only our friend can understand what we're talking about. Okay, it turns out that the method that we're about to use, this bifid business, requires messages to have an even number of letters. That will become clear soon enough. But retreat has only 7 letters. So we need to have 8. So we're just going to stick a dummy letter at the end. And X is pretty uncommon, so we'll just stick an X at the end. And when our friend reads the message and it says retreat X, hopefully they'll be smart enough to understand that we're telling them to retreat. Yeah? Okay, so here's what we do. You write the word retreat X at the end, right up there. You have an even number of letters. Now we've got this square, and we're going to read off the row and the column for each letter. So find the letter R inside of the square. What row and what column is it in? So we got to make sure we get it in the right order. Is it 3-4 or 4-3? 4-3. Row first, column second. We find the R right there is 4th row, 3rd column. 4-3. With your neighbors, fill in the rest of that grid. Look up each letter one at a time and make sure your neighbors agree. Okay, any questions so far? Okay, so here's the funny part. We're going to take these this information, which was put into columns, right? 4 and 3 together tell us the letter R. It's a column. And then 2 and 2 tell us the letter E. It's a column, right? We're going to now change it into a row. So I'm going to circle those 2 numbers. Instead of a 2-number column, which is where it came from, I'm going to kind of mess it up and think of it as a row. And in fact, I'm going to ask you guys to circle every pair of numbers in both rows. Everybody see it so far? Okay, and now that we've got these numbers in rows, we're going to look up 4-2 in the grid. 4-2 still means fourth row, second column. What letter do we see in the fourth row, second column? Q. So 4-2 is the letter Q. That's the first letter in our encrypted message. The next thing that's circled is 2-4, row, then column. So 2 and then 4 is an A. Everybody see it? Next one is 2-2, E. 2-5, L. And then you just pick right up in the second row. So the next one is 3-2. Ed. Sure, 4-letter blocks are fine. Okay, so 3-2 in the next row is, what is that, G? Did I get it right? G-H-A-H. Okay. All right, there it is. What does it really mean? It means retreat with an X at the end. So why is this so hard for somebody to figure out if they don't have, like they don't have our keyword here? Well, let's take a look at the letter R. What did this first R get translated to? It's Q. First letter in here is Q, right? Then there's another R. What was that one? Isn't that the L? So on the one hand, R became Q, but then the other R became L. This is not a substitution cipher. There's no way somebody can look at this and say, oh, the most common letters are E and T and A, and I'm just going to try guessing, because it doesn't stay consistent. Right? I see 2 H's here. What did those 2 H's come from? The E and the T. So you can have one letter that's the same, but it becomes 2 different things. And you can have 2 letters that look the same in the answer, but they actually came from different things. So there's no way somebody could do like a frequency analysis on this. It's really hard. Okay, so this is how we encode or encrypt using this thing called the BIFID method. Questions on that? It's a lot tougher. It's tougher on you guys, but it's also way tougher to figure out what the message is. Ed? If anything in the, wait, are you talking about the keyword confidential or the message? Okay, so if anything in the keyword or the message has a J, just change it to an I. We'll just like automatically change all J's to I's. Yeah. Okay, so that's that method. Let's see, I think we've answered this question. Is BIFID, so we just did, a substitution cipher where every time you see a letter, it always becomes the same letter? No, it's not. That's one of the strengths of this method. Nope. Okay, so that's BIFID going in the encrypting way. Now we're going to go in the decrypting way. So let's give this a shot. 23. Here's a message, SAWA, blah, blah, blah. It was encoded with the BIFID cipher. That is not enough information. What else do you need to know? You need the keyword. BIFID cipher is meaningless without the word confidential. If we change the word confidential, we would have changed the way we encrypted that message. So here the keyword is, where is it? Schwarzenegger. So we're going to fill the keyword in very carefully in this BIFID, in this Polybius square. And be careful not to duplicate any letters. So for me, I ended on a G, last space in the second row. And then you fill in the rest of the alphabet, beginning with what letter? Beginning with A, except A is already up there. So really you start with a B. So very carefully fill everything in. What are we looking for in the last square? Z. Tricky, tricky. What are we looking for in the last square here? We're looking for a Y in the last square here. Okay, so here's the message. Sawa, blah, blah, blah. So let's look up the information here. All right, so the S, where do you see the S? Row, then column. Is 2 and then a 1. Oh, wait. 1 and 1. 1 and 1. Now it used to be, don't write this, but it used to be we would write row and then column this way, right? 1 and 1. But take a look at how we ended up writing the information here. See the circling that we did? When we encoded it, we actually wrote we got the information horizontally. So here, it's not a good idea to write 1, 1 this way. It's actually 1, 1 this way. It's already been circled, and it's this way. So it's fine to write row and column, but when we are decoding this message, we got to write the info horizontally. Okay, next letter is A. Okay, so A is in 1 and 5. We don't write row column the normal way because we're going backwards. We're going the other direction here. So we write 1 and 5 horizontally. So in my head, I'm imagining somebody took this data and they decided to regroup it. They circled them in pairs like this. Okay, so we're going to ask people to continue to decode. There's one funny thing that has to happen. At some point, we need to start populating the bottom row here. How do we know when it's time to start writing the numbers in the bottom row? It's halfway through. So I'm going to put it halfway through right here. As soon as you get to that blue line in the middle, that's when you start writing the numbers in the bottom row, okay? So keep writing. You should have 8 pairs of numbers in that top row before you start writing in the bottom row. Okay, so once we've got all the information here, I'm going to circle and then erase. So again, we wrote the information this way. If it helps you, you can circle them in pairs that way. But we are now reading it the normal way, where the row is the first number above and the column is the second number below. So I'm going to undo those two things and now regroup it, just going the other direction. So for example, row 1, column 3, what letter is there? Is an H. So this first letter is an H. Row 1, column 5 is an A. So keep going all the way through. If you get the message, please do not say it out loud. You'll ruin it for everybody. But just very carefully try grabbing those letters one at a time.